The asteroid belt is a region of space between the orbits of Mars and Jupiter where the majority of asteroids in the solar system can be found. It probably contains millions of asteroids. These might be materials that never came together to form a planet, or the remnants of a planet that was destroyed at some point in the past. Some asteroids are small, at less than a mile long, and others are much larger. Some of the objects in the asteroid belt have captured the attention and interest of astronomers. But before we get into more about the region itself, let's take a look at exactly what asteroids are. Asteroids are also sometimes called minor planets, although this is a category that can also extend to include other objects such as dwarf planets. They are rocky and airless remnants left over from the start of the solar system. They can range in size from less than 33 feet across to as many as 320 miles in diameter at the largest. Although they can be pretty big, asteroids don't take up a whole lot of mass. The total mass of all asteroids combined is estimated to be less than that of Earth's moon. Every now and then, asteroids are nudged by the gravity of nearby planets, mostly Mars and Jupiter because they're closest to the asteroid belt, until they drift into Earth's neighborhood. These are called near-Earth objects, or NEOs, and scientists know about more than 35,000 of them. Most asteroids are irregularly shaped and look a little funky. Some are almost spherical. Their surfaces are often pitted and cratered. Along with revolving around the sun in often elliptical and inclined orbits, they also rotate. Their rotation can sometimes be erratic, and it wouldn't be inaccurate to say they're just tumbling through space. Asteroids don't always make their journey around the sun alone. Scientists have identified over 150 of them that have a moon, and some even have two moons. In addition to these, there are also binary asteroids, which are a pair that orbit each other, and there are even triple asteroids, which, as the name might suggest, involve three instead of just two. In terms of their composition, asteroids are typically broken up into three broad classes. First, there's the C-type asteroids, which are the most common ones overall. They probably consist of clay and silicate rock. They're dark in appearance, and they seem to be among the most ancient objects in the solar system. Next, we have the S-type asteroids. These are made up of a combination of silicate materials and nickel-iron alloys. Finally, there's M-type, which are metallic and also often made of nickel and iron. There are also much less common subtypes that are related to features of the asteroid's surfaces. Asteroids differ in their composition because of how far out from the sun they were when they first formed. Some that were closer to the sun experienced higher temperatures, and this caused them to partially melt. This caused iron to sink to the center and basaltic lava to be forced to the surface. While most asteroids are perfectly happy to keep orbiting the sun, others just really want to get the heck out of here. Sometimes Jupiter's gravity can change their orbits, along with close encounters with Mars and other objects. All of these can knock asteroids out of the main belt and send them through space in all different directions, including across the orbits of other planets. It's like they're playing a fun little game of solar system dodgeball. Along with their composition classes, asteroids can also be categorized by where exactly they float around in space. There's the main asteroid belt, which is estimated to contain between 1.1 and 1.9 million asteroids larger than a kilometer in diameter. There are probably millions of smaller ones in addition to these. When Jupiter formed at the very start of the solar system, it's thought to have brought an end to the formation of any other planets in the same region. Its gravity caused smaller bodies to collide with one another, and that leaves us with the main asteroid belt that we see today. There are also Trojan asteroids, which share the orbit of one of the planets. They move along the same general path either in front of or behind the planet. Despite their proximity, they never collide because Trojans gather around a specific point in the planet's orbit. These areas are known as the L4 and L5 Lagrangian points. At these points, the gravitational pulls from the sun and the planet keep the Trojans in place and prevent them from flying out of orbit. Jupiter Trojans make up the largest portion of Trojan asteroids, and the number is thought to rival even the asteroids in the asteroid belt. But other planets have Trojans as well. In fact, Mercury and Saturn are the only planets not currently known to have any Trojans at all. Earth has a single Trojan, which was announced in 2011. Finally, there are near-Earth asteroids. These are objects with orbits that pass close to that of Earth. Any asteroids that actually cross Earth's orbital path are known as Earth crossers. crossers. So now that we've had a good rundown about asteroids, let's take a closer look at the asteroid belt. The solar system was born out of a massive disk of spinning material. When the sun formed, it hogged over 99% of this material, and the majority of what remained became the planets. Other bits became the various moons across the solar system. However, between the orbits of Mars and Jupiter, there remained a bunch of material that never came together into a larger object at all, and this region is the asteroid belt. There has long been speculation that the asteroid belt is the remains of a destroyed planet, but because the total mass of the asteroid belt is less than that of Earth's moon, it's not nearly enough to have ever been a planet. Instead, it's more likely that everything in the region is shepherded by Jupiter and prevented from coming together at all. The asteroid belt is not a totally unique feature to our solar system. Other stars and stellar systems show signs of regions similar to it, so it's possible that something like the asteroid belt is a pretty common feature. The asteroid belt spans a region of about 140 million miles across. Along with asteroids, it also contains the dwarf planet Ceres. This was the first object discovered in the region, and it's also the only dwarf planet that is not located beyond the orbit of Neptune. Despite the high number of objects in the region, the asteroid belt isn't particularly dense. Plenty of spacecraft have flown through it without any incidents at all. It would actually be pretty hard for a spacecraft to accidentally crash into an asteroid. In order to reach one of these space rocks, you'd have to actually aim for it. Across the asteroid belt are relatively empty regions called Kirkwood gaps. These correspond to orbital resonances with Jupiter. The solar system's biggest planet's gravitational pull keeps these regions emptier than the rest of the belt. The gaps also serve to split the asteroid belt into its inner, middle, and outer regions. So how did we even learn that the asteroid belt was there? A German astronomer by the name of Johann Titius noted a mathematical pattern in the layout of the planets. Using this, he predicted the existence of one between Mars and Jupiter. This then sparked a search for the unseen planet. In 1800, a group of astronomers formed a group called the Celestial Police. Together, they searched the skies for the missing planet, but the discovery of the first body that seemed promising didn't even come from the Celestial Police. It came from Giuseppe Piazzi, an Italian astronomer. He named the body Ceres. Less than a year later, a second body was discovered, and it was named Pallas. For some time, both Ceres and Pallas were regarded as planets, but eventually, as astronomers kept searching the region where these two bodies orbited, they found over 100 more objects. Scientists eventually realized that all of these were much too small to be planets, and so they started calling them asteroids instead. As it is now known, there was never a planet between Mars and Jupiter, and Jupiter is almost exclusively to blame for that. But even though the assumption that there would be a planet there was incorrect, it still led to the discovery of the asteroid belt. Now that we've covered what the asteroid belt is and how it was found, why don't we take a look at some interesting asteroids? Vesta, also known as 4 Vesta, was discovered on March 29, 1807 by Heinrich Wilhelm Olbers, who previously discovered Pallas. He incorrectly proposed that Ceres and Pallas were fragments of a destroyed planet. While searching for more such objects, he found Vesta. It was the 4th asteroid to ever be discovered, which is where the 4 in its designation comes from. Olbers gave the honor of naming the asteroid to German mathematician Carl Friedrich Gauss, who computed the asteroid's orbit. Gauss chose to name it after Vesta, the Roman goddess of the hearth and home. Vesta is the second most massive body in the main asteroid belt. It accounts for almost 9% of the total mass of all asteroids. Only the dwarf planet Ceres holds more mass than it. Because it's almost spherical, Vesta is nearly classified as a dwarf planet. It's unique compared to many other asteroids in that it is differentiated. This means its interior is separated into a core, mantle, and crust. NASA's Dawn mission aimed to answer the question of why Vesta is differentiated. As it turned out, Vesta formed extremely early, within just 1 or 2 million years of the solar system's birth. During this time, short-lived radioactive material was incorporated into the bodies that formed. This caused the bodies to heat up and melt, causing higher density materials to sink towards the center, while lower density materials rose to the surface. Vesta has one of the largest ranges of brightness of any rocky body in the solar system. Its bright materials are thought to be rocks that are native to the asteroid, while the darker materials are thought to have been deposited by other asteroids crashing into it. Around its equatorial region is a large system of troughs. The largest of these, which is named Divalia Fossa, is larger than the Grand canyon. Less than 1 billion years ago, Vesta is thought to have lost about 1% of its mass in a massive collision. This event may have been responsible for the Rhea Silvia crater, which is about 310 miles wide. The Vesta family of asteroids are probably a bunch of debris from this collision. Another huge crater on the surface is Venonea, which is about 250 miles in diameter. We have pieces of Vesta here on Earth, not because any spacecraft went out to collect them, but because they fell here on their own. These are the Howardite, Eucrite, and Diogenite groups of meteorites, and they're thought to originate from the crust of Vesta. It's possible these pieces of Vesta were knocked off of it in the very same impact that created the Rhea Silvia crater. Psyche was discovered on March 17, 1852 by Italian astronomer Annibale de Gasparis. It's named after the Greek goddess of the soul, and it's also known as 16 Psyche. Psyche is a giant metal-rich asteroid. It has an irregular shape, being 173 miles wide at its widest point and about 144 miles long. Its surface area is a total of about 64,000 square miles. Psyche orbits the Sun at a distance ranging from 235 to 309 million miles. It takes around 5 years to complete one orbit. It rotates on its axis and completes one spin in just over 4 hours. Until recently, scientific consensus held that Psyche consisted mostly of metal. However, more recent data suggests that it may be a mix of metal and silicate. The best analysis available suggests a mixture of rock and metal, with metal composing between 30 and 60% of Psyche's volume. By combining radar and optical observations, scientists created a 3D model of Psyche. This model shows evidence of crater-like depressions. There are a few main theories about Psyche's origin. One states that it's the remnant core of a planet that lost the rest of its material through repeated collisions. However, that seems unlikely, partly because Psyche is nowhere near dense enough to be a planet's core. It would also make sense if such a series of collisions created a family of more asteroids around Psyche, but no such family has been observed. A second theory proposes that Psyche may have been damaged by multiple impacts, but not completely broken apart. In this case, it could be the source of another group of meteorites on Earth called the Mesositerites. And a third option is that Psyche is differentiated, like Ceres and Vesta, but that it has experienced a kind of iron volcanism called ferrovolcanism. This basically means it's had volcanic eruptions that spewed molten iron to the surface. A spacecraft is currently on its way to Psyche. This spacecraft belongs to the aptly named Psyche mission. It should arrive in August of 2029, and it'll allow us to learn even more about this asteroid. Bennu was discovered on September 11th, 1999. It's a carbon-rich asteroid about 1/3 of a mile wide at its equator, and its shape resembles a spinning top. Its original designation was 1999 RQ-36. Its current name, Bennu, comes from an ancient Egyptian deity. It was picked by 9-year-old Michael Puzio, who won a naming competition. Bennu is more than 4.5 billion years old. Within just 10 million years of the solar system's formation, its current-day composition had already been established. It's likely that Bennu broke off from a much larger asteroid between 700 million and 2 billion years ago. It may have formed in the main asteroid belt, but it's drifted much closer to Earth since then. At an average distance of about 105 million miles from the Sun, Bennu completes an orbit every 1.2 years. A rotation of the asteroid takes just 4.3 hours. Every 6 years, Bennu makes a close approach to Earth. The exact distance between the two bodies varies with each approach. Its orbital path is tilted by about 5 degrees relative to Earth's, and its equator is tilted by about 175 degrees relative to the plane of the planets. This means its north pole is pointing down relative to Earth's. Bennu was the target of NASA's first asteroid sample return mission, which was referred to as OSIRIS-REx. The spacecraft dropped off a sample of Bennu on September 24th, 2023. After this delivery, it began a new mission as OSIRIS-APEX and departed again for a 2029 encounter with Apophis. The OSIRIS-REx mission team found a surface littered with boulders, which was very different from the sort of smooth and sandy texture they had expected based on observations from telescopes based on Earth and in space. They also discovered that Bennu appeared to be spitting particles of rock into space. Analysis of data gathered when OSIRIS-REx collected a sample revealed something surprising. If the spacecraft hadn't fired its thrusters immediately to back away after collecting a sample, it would have fallen into Bennu. The particles making up Bennu's surface and exterior are so loosely packed and lightly bound that someone stepping onto the surface would feel very little resistance. Apophis was discovered on June 19, 2004 by astronomers Ray Tucker, David Tholen, and Fabrizio Bernardi at Kitt Peak National Observatory in Tucson, Arizona. Its name comes from a demon serpent who personified evil and chaos in ancient Egyptian mythology. However, the name Apophis is actually the Greek name for this deity, while the Egyptian name is Apep. Apophis is a near-Earth asteroid estimated to be about 1,100 feet across. It completes an orbit around the Sun every 0.9 years and rotates once every 30 hours. It's classified as an S-type asteroid. Radar images suggest it's elongated and possibly has 2 lobes, which would make it look something like a peanut. When it was discovered, Apophis was identified as one of the most hazardous asteroids that could impact Earth. The impact assessment changed after astronomers tracked Apophis and better determined its orbit. A radar observation campaign in March 2021, along with a more precise analysis of its orbit, helped determine that Apophis poses no risk of colliding with Earth anytime in the next century. On April 13, 2029, Apophis will pass by Earth less than 20,000 miles from the surface. This is much closer than the Moon and even geosynchronous satellites. During this encounter, it will be visible to observers on the ground in the Eastern Hemisphere without the need for a telescope or binoculars. The OSIRIS-REx spacecraft, after completing a sample collection of Bennu and delivering it back to Earth, was renamed to the OSIRIS-Apophis Explorer, or OSIRIS-APEX. It was then sent to study Apophis during its flyby in 2029. Didymos was discovered on April 11, 1996 by researcher Joseph Montani of Spacewatch at Kitt Peak National Observatory in Tucson, Arizona. He also suggested the name, which means twin in Greek. After scientists spotted echoes in data from the Goldstone solar system radar, suspicions arose that Didymos may have a moon. These were confirmed by analyzing the asteroid's brightness over a period of time, along with radar images from the Arecibo Observatory in Puerto Rico taken on November 23, 2003. The moon was named Dimorphos, which is Greek for having 2 forms. Didymos is about half a mile in diameter, while Dimorphos is much smaller at just 525 feet. The orbit of Didymos ranges from just outside Earth's orbit to beyond the orbit of Mars. It's slightly inclined by about 3 degrees with respect to the plane of the planets. One trip around the Sun takes it about 2.11 years. Didymos takes only 2.26 hours to rotate once. This rapid spin gives scientists an idea of how Dimorphos may have formed. Didymos may have started spinning so fast because infrared light began emitting unevenly from its sun-warmed surface. This resulted in a sort of twisting force. Over millions of years, the process could have built up enough momentum to start sending material flying off of the surface, and this material could have later come together to form Dimorphos. Didymos and Dimorphos pose no threat to Earth, but they do come pretty close to us. Because of this, they were chosen as the target of NASA's Double Asteroid Redirection Test Mission, or DART. This was the agency's first ever mission to test planetary defense technology. DART deliberately impacted Dimorphos on September 26, 2022. On October 11th of the same year, NASA announced that the impact had affected the asteroid's orbit. Its orbital period around Didymos of around 11 hours and 55 minutes had been shortened by about 23 minutes. This marked the first time humanity had purposefully changed the orbit of a celestial object and the first full-scale demonstration of asteroid deflection technology. Eros was discovered on August 13, 1898 by Gustav Witt, the director of the Urania Observatory in Berlin. On the same day, it was independently discovered by Auguste H.P. Charlois in Nice, France. It takes its name from the Greek god of love. Witt's discovery was a bit of an accident. He was taking a 2-hour exposure of an entirely different asteroid, 185 Unique. The image he produced showed a strange 0.4 millimeter trail. Observations on the following evening identified this object as one of unusually high apparent motion in the sky. Less than 2 weeks later, Adolf J. Berberich computed the object's orbit, which brought it well within the orbit of Mars. This made Eros the first known near-Earth asteroid. Astronomers used Eros to help them calculate the mass of the Earth-Moon system, as well as the value of the astronomical unit. This was before ground-based radar was available to observe observe extraterrestrial bodies. Eros was observed by ground-based telescopes for a century before it became the first asteroid to be orbited by a spacecraft. The NEAR spacecraft first flew by it on December 23, 1998 at a distance of about 2,400 miles. It found that Eros was smaller than expected and had two medium-sized craters, a long surface ridge, and a density similar to Earth's crust. On February 14, 2000, it moved into orbit around the asteroid. NEAR orbited Eros for almost a year before landing on its surface on February 12, 2001. Though it wasn't expected to survive the landing, its instruments remained operational. It issued its final transmission from the surface of Eros on March 1, 2001. Ida was discovered on September 19, 1884 by Austrian astronomer Johann Palisa at the Vienna Observatory. Its moon, Dactyl, was found on February 17, 1994 by Anne Harch of the Galileo imaging team. This made Ida the first asteroid that was known to have its own moon. Ida was named by Maurice von Kuffner, a Viennese brewer and amateur astronomer. The name comes from a nymph in Greek mythology who was entrusted with the care of infant Zeus, along with her sister Adrasteia. Adrasteia is a name that has also been given to both another asteroid and a moon of Jupiter. Dactyl's name comes from the mythological creatures that lived on Mount Ida on the island of Crete. On August 18, 1993, the Galileo spacecraft flew by Ida at a distance of about 1,500 miles while it was on its way to Jupiter. A little more than 5 months later, scientists studying the images it captured noticed a tiny moon. Ida is located in the main belt. It's part of the Coronus family of asteroids, and it's thought to be debris from an ancient collision between two larger objects. Its surface is covered in craters as well as a deep layer of regolith, or pulverized rock. The age of the asteroid is uncertain. The craters suggest it's old, but just being part of the Coronus family suggests it's actually young instead. Itokawa was discovered on September 26, 1998 by the Lincoln Laboratory Near-Earth Asteroid Research Team at Socorro, New Mexico. It's named after Hideo Itokawa, who is regarded as the father of Japanese rocketry. In 2005, Itokawa became the first asteroid from which samples were collected and then brought back to Earth. The Japanese spacecraft Hayabusa touched down on the asteroid and collected a small bit of dust from its surface, despite the failure of the mechanism that was designed for this purpose. It delivered the sample back to Earth on June 13, 2010, although the spacecraft itself largely burned up upon re-entry. Observations from Hayabusa and analysis of the collected dust support the conclusion that Itokawa is what remains from a larger object. This object would have been shattered by a collision. The mission and analysis also confirmed, or at least suggested, that S-type asteroids such as Itokawa are the source of ordinary chondrites, which are the most common type of meteorite on Earth. Scientists suspect that Itokawa is not fully solid, but instead a rubble pile. These are bodies, typically small ones, that are made up of multiple pieces of debris held together loosely by gravity. Itokawa's surface has few visible craters. This is probably because any impact with enough energy to make a crater just shakes a bunch of rocks loose and they then fill the hole. Many of the captured dust particles from Hayabusa show signs that they slowly cooled after forming deep inside a rocky object at a temperature of around 1,500 degrees Fahrenheit. For this to have occurred, the diameter of the rocky object would have to be greater than 12 miles. But Itokawa's largest dimension is just 0.3 miles, so this supports the idea that Itokawa is a remnant of a larger object. The largest boulder found on Itokawa is about 160 feet across. It's too big to have been ejected from an impact that created the asteroid's largest crater. It may instead be a fragment of the cataclysmic event that resulted in the asteroid's current construction. The Hayabusa team described Itokawa's shape as resembling a sea otter with a head and a body. There are a couple explanations for this shape. For one, after the parent body was destroyed, the slight mutual gravity between the remnants could have pulled them into two or more rubble piles. Then two piles eventually bumped into each other and stuck together. Alternatively, Itokawa may have originally been one rubble pile. A large impact might have broken off a chunk, and gravity eventually brought it back and reattached it in a slightly different way from before. Sylvia was discovered in 1866. It's named after Rhea Silvia, who is the mythological mother of the founders of Rome, Remus and Romulus. It's a a very large asteroid that orbits at the outer reaches of the main asteroid belt. One trip around the Sun takes it about 6.49 years, and it rotates once every 5.18 hours. At about 157 miles in diameter, Sylvia is larger than most asteroids, and its size is comparable to that of West Virginia. It likely contains iron, nickel, and cobalt. Most notably, Sylvia is the first asteroid found to be accompanied by 2 moons. These moons are named Remus and Romulus after Rhea Sylvia's sons. Romulus was discovered in 2001, while Remus was found in 2005. The names weren't proposed until after Remus was discovered. The discovery of the moons allowed scientists to determine Sylvia's mass and density. This revealed it's extremely porous, with about 60% of its interior just being empty space. Because of this, it's possible Sylvia formed when 2 larger asteroids collided and broke apart. In this collision, most of the fragments would have come together to form Sylvia, making it a rubble pile. Its moons probably came from debris that was left over from the very same collision. The asteroid belt is a very interesting part of the solar system, and it gives us a lot of clues and insight about the solar system's history. There are so many different objects out there, and while you could dismiss most of them as just a bunch of rocks floating in space, isn't that just what Earth is too at the end of the day? You may have noticed there's one important object in the asteroid belt that I didn't really mention here, and that would be Ceres. I'm going to make a separate video about it though, because it's a dwarf planet, and so I might as well give it its own spotlight. I hope you had fun learning about the asteroid belt, and I also hope you stick around if you're interested in seeing my video on Ceres. I have plenty of other videos on the solar system that you can watch in the meantime. Thank you for watching, like and subscribe if you enjoyed, and have a good day.